Some ROS nodes use a lot of parameters to fully configure their behavior. Managing all of these parameters in a launch file can get pretty complicated. Luckily, we can load parameters from YAML files. This gives us a place to put all of our parameter values in a clean and organized way. Just like launch files, we'll add a folder to our package for all of our parameter files. This folder is usually called config. And we'll need to tell CMake to install that folder. We can just add it to the same install command we used for our launch folder. This will install both of those folders side by side at the same destination. Now let's move our TurtleSim background color parameters into a parameter file and modify our launch files to load them from there. In our config folder, we'll create a new file, turtlesimparams.yaml, and set up the structure for our parameter file. And this is what that structure looks like. The root of this YAML file is a map, where each entry shares its name with the node it's setting the parameters for. The next line tells us that we're setting ROS parameters using the ROS _parameters key, and then all of the lines within that key are parameter names and the values we want them to have. So this file right now is just defining the same 3 background RGB values that we've been using throughout the launch file demos. To load this file from an XML launch file, we can use a different variation of the param tag. In this case, instead of giving it the name and value attributes, we just give it one attribute called from. The value of this from attribute should be set to the full path of our parameters file. To get that path, we use another substitution expression, using the keyword findPackageShare and the package name RJTraining. This will get resolved to the full install path for our RJTraining package's shared resources. The rest of our value here is just the rest of the path. We know that there will be a config folder, and we know that within that config folder we want the turtlesimparams.yaml file. We can now open up a terminal and build our workspace. And now when we launch our demo.launch.xml launch file, we see that the parameters from our YAML file have taken effect. Now let's go look at how to do the same thing in our Python launch file. And here's what that looks like in our Python launch file. We've imported 2 new utilities. We're importing the OS package from Python's standard library, and then we're importing the getPackageShare directory function from the AMET-index Python package. This function will perform the same task as our substitution expression findPackageShare did in the XML file. Now when we launch our TurtleSim node, we're going to give it the path to our YAML file as the parameter source instead of a dictionary of parameter values. We use os.path.join to concatenate several pieces of a path, where the first piece is the result of our getPackageShare directory call, giving it the name of our package, RJTraining. The next piece is the config folder, and then within that, our turtlesimparams.yaml file. Now we can build our workspace and launch our Python launch file, and we see that we got the same behavior. It's loading the parameter values from our YAML configuration file. That's how we can load parameters from a file. Another way for us to generate these parameter files, though, is using the ROS2 command line tool. We can save a parameter file based on the current parameter values of a running node. We'll use our Python launch file to start up our nodes so that we have the TurtleSim node running. And then in another terminal, we can use the command ros2 param dump and then the name of the node, in this case TurtleSim, and that will save a file locally named turtlesim.yaml. And if we look into the contents of that file, we will see that same YAML parameter file structure that has generated the YAML file for us using all of the current parameter values of our TurtleSim node. There's one more thing for us to cover about parameter files. If you ever see a parameter file that matches this pattern, this means that the parameters in this section will apply to any node that loads this file, regardless of the node's actual name. This is a wildcard pattern that makes it easy to set common parameters needed by multiple nodes. And that's it for parameter files. They're super useful for keeping our parameter values organized without cluttering up our launch files.